Welcome to the fourth SkelForm tutorial, where we will be going over physics. As always, I will be using the Chibington sample from the third tutorial, but you can use your own character as you follow along. So in the previous video, we went over mesh deformation for Chibington. So all of the limbs already have meshes. And for this tutorial, what we will do now is we will add physics for some of the elements. So in this case in particular, I'm thinking of adding physics for the hat. And the way I would want it to work is that whenever the hat is moved, the top part and maybe even the sides here would flop a little. So they would like bounce around or they would wiggle around when you move them. It would make it look more dynamic and it would make it look like an actual cloth piece because that's how hats look. What I'm going to do now is I'm going to turn this hat into a mesh, which I previously did in the other tutorial, but then I turned it back into a regular texture. But what I'm going to do now is I'm going to just make a quick trace of it. I'm going to clean it up, and then we will move on to creating the binds for the top side and maybe even the left and the right side. So here we have the mesh properly set up. I've trimmed it to only the necessary vertices and I have the top bind. So now what I'm going to do is over here on the right side, if you select the bind, you'll see that there is a physics section. In fact, the physics section applies to pretty much all of the bones, although some of them will have more options. I will go into that later. But right now we have a few sliders here, which are the position, scale, and rotation damping. Now what damping means is that, let's say for example, a bone's position should be changed depending on whether, for example, its parent is moving around. What we can do with position damping, for example, is we can make it so that if we set it to a value like 40, and if we were to move the hat right now, you can see that the top part, which is this green circle here, you can see that now it's going to end up where it should be based on the hat parent, but instead of immediately setting the position, it's going to slowly get there. So it's going to be like an interpolation if you want to think about it like that. So for example, if we make it an even bigger value, the damping will be even stronger, so it will be even slower in that case. And this is the kind of pseudo physics effects that SkelForm supports. It's not realistic physics, but it's definitely you can definitely get some cartoony effects with it. So if we were to set it to a more reasonable value, like for example 20, I think this would actually, yeah, this looks more like how a hat would behave. But in our case, actually, what we want instead is this one, the sway factor. And what this one will do is if we set it to a value like, let's say for example 3, what this will do is that when we move the hat now, you can see that the top part is going to be rotated depending on the momentum. So for example, if I move the hat to the right side, you can see that the top part, let me just do it again. You can see that the top part is now moving, like it's swaying over to the left. Actually, to the camera, it's actually going to be like this. Yeah, so it's swaying over to the left because the momentum is going to the right side. So for example, if we were to do the opposite, you would see that now the top, if we were to move it to the left, you can see that now the top is actually swaying over to the right. So this is like, you can imagine it as wind, basically, or just like air resistance from moving an object around. So for example, if I were to move it up, it would realistically go down. And if I were to move it down, it would be pointing upwards. So for example, if you were to make a falling animation, you would expect the hat to behave like that. Or if you were to make an animation where the hat is elevating, the top part of the hat would realistically start flopping downwards. So something like this. Like something like this, yeah. This is better. Of course, it looks a little weird right now because of the way that the vertices are set up. I could actually improve this by adding a few more vertices, maybe changing where the top is. Perhaps you could even add more binds to the top and you could make it a lot more elaborate. But for demonstration purposes, I think this does the job quite well. So if we just put the hat where it should be, and if we were, let's say that we were to move the entire character around, you can see that it does actually work as well. You can see that this is how it would look like if the, yeah. So now it looks a lot more dynamic in general, since it looks like an actual cloth piece. And if we were to, let me just put him in the center. If we were to check out, for example, the running animation, since in the running animation, Chibington jumps up and down, right? So you can see the effect of the physics here, just from the running animation alone. I'm not moving him at all. And you can see that the hat already has that wobble effect going on. For this tutorial, I have also separated the bow tie and the torso, so they are now two textures instead of the older one where they were together. And the reason I separated them is because I want to show a physics demonstration with the bow tie as well. So it would be, I guess we can create a new bone here, call it bone tie, and we'll use the new bone tie texture, and also for the torso we'll actually change it to the new one. For the bow tie, what we can do is we can also do the same thing with the meshes. So I will turn it into a mesh very quickly, and then I can put up two binds for it, and the two binds will be for the left and the right side of the bow tie. And then what I want to be able to do is whenever I move the bow tie, I want to make it so that both flaps will have position damping in them, or maybe even swaying, so that they will like go up or go down and maybe sway left and right as you are moving them left and right. So I wanted something like this. So if I move the bow tie up and down, you can see that it's swaying about. And if I move it to the left and right, you can also see that the way that it sways is somewhat accurate, maybe even a bit realistic. But you can definitely see how it feels a lot more dynamic, and it really feels like a cloth piece because of how smooth and soft it looks. If I were to position it now to where it would be, and if I were to now move Chibington around, you can see that now both of them look very dynamic. One thing I want to mention as well, there's actually one slider that I haven't mentioned yet, which is sway bouncing. What sway bouncing does is instead of just allowing the bone to sway exactly to where it needs to once it's been moved, as it's trying to sway back into place, it'll swing back and forth as if it were bouncing. So if we were to set the sway bounce to maybe something like 0.75, and if we were to move the hat around, because I changed the top bind, if we were to move the hat around, you can see that now it looks like it's bouncing. You can make it more dramatic by setting it to an even higher value, and this is a bit much, but you definitely get the point. It actually kind of looks like jelly now. Now, for sway bouncing to show up in the editor, you do need to have at least a bit of sway factor. So even something like 0.01 sway factor will activate the slider. But otherwise, you won't be able to bounce it because it doesn't really make sense to be able to bounce it without also swaying it. One last thing I want to go over is ratios. All of the damping sliders will have an option called a ratio if you set it to more than 0. So in this case, if I were to, let's say that it's set to 0 right now, if I were to slide it, immediately we would have a new ratio slider. And what this does is, depending on whether it's on the left or the right side, either the X or the Y axis of the bone will not be affected by the damping. So in this case, if I were to move it all the way to the left side, the Y axis will not be affected. If I set the ratio to the left side for both binds, and if I were to move the bow tie now, if I were to move it to the left and right, you'll see that the damping is still there. It still works the same. But if I were to move it up and down, you'll see that the effect isn't noticeable at all. And that's because the ratio is on the left side, meaning that the Y is practically at 0 right now. If I were to set it to 0.5 for both of them, you'll see that now it does have an effect, but it's a lot lower than the x-axis. On the x-axis, it would be half as quick than the y-axis, because the y is now set to 0.5. Now we can also do the opposite, and we can set it all the way to the right side to turn off the x-axis. So it essentially doesn't do any damping on the left and right, but it will still do damping on up and down. And of course, the same thing will apply if we were to set the x to 0.5. So now it will be double as fast as the y-axis. I think the effect would probably be more noticeable with maybe, let's set it to a lower value, like maybe 0.20. You'll see that now the x is infinitely faster than the y. Yeah, the effect is much more noticeable this way. But this is basically how you can control how much power both axes have. That will be all for this tutorial. We've gone over everything that physics has to offer, like damping, swaying, bouncing, and ratios. In the next tutorial, we will go over the style system and how it can be used for skins and outfits. That will be all for this tutorial. See you next time!